So hi children, in that previous video we discussed up to 13 questions, no? So in this video we are going to discuss the questions from 14 onwards, okay? So let us see that here 14th question what they given. If A, B, C, D, here P is not there. So A, B, C, D are distinct real numbers such that A square plus B square plus C square into X square minus 2X into AB plus BC plus CD plus B square plus C square plus D square is less than or equals to 0. Okay, so here then A, B, C, D satisfies. So first what we have to find means A square plus B square plus C square into X square minus 2X into AB plus BC plus CD plus B square plus C square plus D square is less than equals to 0. So that quadratic inequality is given, no? So here, so see here ma. So that quadratic equation here they given this expression. So first we have to simplify this expression. After we have to go for that A, B, C, D are in either are in AP or ZP or HP or the relation we need to find out. Understand? So let us see that. Okay. So what they given ma here? A square plus B square plus C square into X square. Okay, into 2x into AB plus BC plus CD plus B square plus C square plus D square is less than equal to 0. Okay, so from this one first simplify this one ma. So A square X square plus B square X square plus C square X square minus 2x into AB. So here minus into plus minus 2x BC minus 2x CD, okay, plus B square plus C square plus D square is less than equals to 0. Understand? Now simplify this. So I want to write that some like terms, okay, some related terms I want to write together. So A square X square, okay, so here AB term is there, no, so I want to write here that is minus 2x AB. Okay, so see here A square X square minus 2x AB. So here 2x means that is the 2AB form. Okay, so X is already there, A is there, so what is that left over here? That is B. So I want to take here B. So plus B square. So this is one of the set. Understand? Now go to the second one. Plus B square X square. Okay, so B square X square is there. So the second term I want to take here, that is minus 2x BC. Okay, so here B term is there, X term is there, so the leftover is C. So take here C plus C square. This is another set. Plus, come to the next one. Here C square X square. C square X square. And the next one here minus 2x CD. And the last one that is D square. This is another set which is less than equal to 0. Understand? Now observe this one children here. This is in the form of A square minus 2AB plus B square. Yes or no? See here. A square means AX whole square minus here plus B square is there, no, minus 2. Here A is equal to AX 2AB plus B square. Understand? So here A square minus 2AB plus B square form is there. So A square minus 2AB plus B square, which is equals to, what is that? A minus B whole square formula this is. A minus B whole square formula that is. So that's why here write this one as AX minus B whole square. Understand? A square X square plus B square minus 2AXB. Clear? And in the same way here, the second term, that is B square X square minus 2XBC plus C square. So we can write this one as BX minus C whole square. Clear? Yes. And then last one is here CX minus D whole square, which is less than equals to 0. So children see here, which is less than equal to 0. Less than equal to 0 means here either that is less than or equal to. Once observe this LHS side expression, so this is the a square plus b square plus c square form is there, or else squares, sum of the squares which is that is never less than 0. Understand why? Because here minus 1 whole square, okay, again we will get it as a positive only, no, minus 1 whole square we will get it as a positive. So 1 square again we will get it as positive. So which means here this value is either positive or negative, whatever it may be, here its square is always positive. So sum of 3 positive integers is always positive. Yes or no? So that's why here sum of 3 positive integers never less than 0. Okay, did you understand this one? So that's why here this condition we have to take this one as ax minus b whole square plus the second one bx minus c whole square plus cx minus d whole square. Cx minus d whole square. So less than or equals to? Yes, this is equals to 0. Why? Because sum of 3, here I'll write, say that sum of positive integers is always positive. Positive or 0. Which means here, which is always not equals to negative. Okay, not equals to negative means those values never equals to negative. Those values are never negative numbers. Okay, so positive or 0. So that's why here the first expression and the second expression and the third expression, sum of the squares of these expressions is equal to 0. When it will be, this is equals to 0, this is equals to 0, and the third term is equals to 0. Third expression is equal to 0, then only this is possible. Understand? So that's why here ax minus b whole square is equal to 0. bx minus c whole square is equal to 0. Next cx minus d whole square is equal to 0. Understand? So from this one ax minus b is equal to 0. Just remove that square. Okay. Next bx minus c is equal to 0. cx minus d is equal to 0. So here ax is equal to minus b become as plus b. Okay. So from this one x is equal to b by a. X is equal to b by a. Next bx is equal to c. So x is equal to c by b. Understand? So the last one cx is equal to d. X is equal to d by c. Understand? So here we got that x is equal to how many values, ma? 3 values we got. So what are those 3 values? Those 3 values also equals to x only, no? So we can write this one as x is equal to b by a, which is equals to c by b, which is equals to d by c. Shall we write like that? So from this one I want to take that first 2 terms here. b by a is equal to c by b. b by a is equal to c by b. So we can take here b square is equal to ac. Yes or no? And in the same way if you want to take these two, okay, then here c by b is equal to d by c. So c square is equal to bd. Understand? Or else if you want to take these two, then what you will get? b by a is equal to d by c. So here bc is equal to ad. Understand? So here 3 conditions we got. But here what they ask ma here? They ask that a, b, c, d satisfy. So that one satisfies what? Here first one they are satisfying that ZP. Why? Because b square is equal to ab. If the numbers ABC are in the form of b square is equal to AC, then ABC are in ZP, we know that. So and in the same way here b square is equal to AC, we got it, right? So that's why here ABC are in ZP. And in the same way when you are going to take these two, what we are getting here? BC is equal to AD. So that answer is there, BC is equal to AD, that is not there. Okay, so that's why ABCD satisfies the condition, that is ZP. Okay, at this place if they will give that BD is equal to AC, then it will be satisfied. Okay, but that condition not given now here, so that's why here which option is correct means option 2 is correct, that is GP. Understand? So let us see that next question. So children, see that next 15th question. Here, if the roots of the equation, here what is that equation? A square plus B square, A square plus B square into X square plus 2 into BC plus AD into X plus C square plus D square is equal to 0. Okay, so these roots are real. So here only they given nature of the roots are real. That condition they given, nature of the roots they given. Then they are asking about the terms A square, BD, C square are in. So after finding this one, here we will get that ABC values, right? ABCD values. But here they are asking A square, BD, C square. So here 3 terms they given. So those 3 terms are in which progression? Either that is arithmetic progression or geometric progression or harmonic progression or arithmetic geometric progression. Arithmetic or geometric progression AGP. So that is related to which one? Okay, so let us see that. So what is the given quadratic equation ma here? A square plus B square into X square plus 2 into BC plus AD into X plus C square plus D square is equal to 0. So whatever it may be, first we need to find the delta value, right? So here delta is equal to B square minus 4AC, right? So here B is equal to, so let us consider from this one, A is equal to here A square plus B square. Next, B is equal to 2 into BC plus AD. Okay, so from this one, C is equal to C square plus D square. Okay, these 3 are the values of ABC. Now substitute those values here. So B is equal to 2 into BC plus AD whole square. B square minus 4 into, here A is equal to A square plus B square into, here C is equal to C square plus D square. Okay, this is the discriminant. So discriminant value we need to find out. So from this one, here 2 square is 4 and here BC plus AD. So BC plus AD we can consider it as A plus B whole square formula, right? So at the place of A here that is BC and the place of B here AD is there. So A plus B whole square formula, here we have to apply that. So B square C square, which means A square plus A square D square, which means B square. Okay, A square plus B square plus 2AB. So 2 into ABCD. So 2ABCD. Clear? So this is the first step. Minus 4 into. Okay. And children see here, they said that the roots are real, they said. So roots are real means here we can take that delta is equal to 0 also, no? Why? Because the roots are real means greater than 0 and in the semi is equal to 0 also there. Okay. So that's why here consider that is equal to 0. Okay. So to find the values of ABCD, so here keep that 0 is equal to 0. So which is equals to, so A square C square plus A square D square, just do the multiplication, and here plus B square C square plus B square D square, which is equal to 0. Clear to you? So children, once observe that here also 4 is there and here also 4 is there. So I want to take that 4 as common from those 2 terms. Okay, from those 2 expressions here I am going to take that 4 as common. So here I taken 4 as common. So B square C square plus A square D square plus 2ABCD. Okay, next minus into minus A square C square. Already I written here 4, so no need to write again. So minus A square C square. Next minus into plus is minus A square D square. Next minus into plus minus B square C square. Next minus into plus minus B square D square, which is equal to 0. Which is equal to 0. So here any cancellation terms? Yes, B square C square and minus B square C square. Okay. Next, a square d square, here also a square d square. Those two terms also cancel. Any other common terms? Not there. Okay, so that's why. See that next one. So here 4 is there, no, and here is equal to after 0 is there. So if you transpose this 4 into that RHS side, then 0 by 4 is equal to, again we will get that 0. Okay, just transpose that 4 into RHS side. So which is equals to, so the leftover terms 2ABCD, 2ABCD, and here minus a square c square, minus a square c square, and here minus b square d square, minus b square d square, which is equals to 0 by 4. Okay, so which is equals to 0. Just transpose that 4 from LHS to RHS, then we will get that 0. Okay, so from this one here we can write it as minus a square c square, okay, plus 2ABCD minus b square d square, which is equal to 0. So children, just observe that here starting minus is there, and here also negative is there, here positive is there. So from this LHS we can take that minus as common. We can take that minus as common. So here a square c square minus 2ABCD plus b square d square, which is equal to 0. So from this one, here just take that minus and just transpose that. So a square c square minus 2ABCD plus b square d square is equal to 0. So children, once observe that this is in the form of a square minus 2, this totally ab plus b square. Same form only, no? A square minus 2ab plus b square form is there or not? Okay, so that's why convert this one into the form of a minus b whole square. So here a is equal to ac and b is equal to bd. Okay, so we can write this one as ac minus bd whole square. Yes or no? ac whole square, a square c square plus b square d square minus 2abcd. Am I clear to you? So from this one, which is equal to 0. Okay, so just remove that square. So AC minus BD is equal to 0. So from this one, AC is equal to BD. So here we got that one of the condition. What is that? AC is equal to BD. So up to here we got this condition, right? So once see that question, here they given some terms. What are those? Here 3 terms they given. No, A square BD C square. A square BD C square. So consider the terms. Consider the terms A square. What is the next term? BD C square. BD C square. Clear? So from this one here, AC is equal to BD. AC is equal to BD. So we can write this one as A square BD C square is equal to, we can write that A square. Here AC is equal to BD, no. So BD is equal to AC. So we can write that AC and C square. Okay. Just substitute this value here. Then those two are equal, right? So from these 3 terms, here we can write that A square, AC, C square are 3 terms. Okay. So here we got the 3 terms. So AC by, just take that, the division of the second term and the first term, next third term and the second term. So from this one, which is equal to C square by AC. So these 2 values we will get the same or not. Okay, is equal to symbol is there, means here must be LHS value is equals to RHS value. So here we are getting that value or not, just check that. So A 1 time is there, here 2 times there, so cancel that 1 time. And here also C 2 times there, here 1 time is there, so cancel that. So the leftover here C by A, which is equal to C by A. So finally we are getting here LHS value is equal to RHS. So children, when you observe that these 3 terms, okay, while you are taking the division of these 3 terms, here we are getting, this is in the form of, if A1, A2, A3, A1, A2, A3 are the terms in a progression, then A2 by A1 is equal to A3 by A2. If this condition satisfies, then those three terms are in geometric progression. Then A1, A2, A3 are in geometric progression. So that's why here A square, AC, C square are in ZP. Okay, so here they asked about these three terms, no? So that's why instead of that place A square, AC is equal to BD, no? So BD, C square are in ZP. So that's what they asked, no, here, no? So they asked here A square, BD and C square are in geometric progression. Are in geometric progression. Am I clear to you, children? Yes. Yes. See here. So the roots of 5x square minus 3x plus 2 is equal to 0. So again they're asking here nature of the roots. Okay. So nature of the roots means here we need to find the delta, right? So what is the given quadratic equation? 5x square minus 3x plus 2 is equal to 0. Okay. Plus 2 is equal to 0. So from this one they are asking here delta. So delta is equal to b square minus 4ac. So b is equal to minus 3 whole square minus 4 into a is equal to 5 and c is equal to 2. So from this one minus 3 whole square, that is 9, minus 4 5 is 20, 22 is 40. So which is equals to minus 31. Okay, 9 minus 40 which is equals to minus 31. So minus 31 means that is less than 0. Yes or no? Negative values means those values are less than 0 only, no? So that's why here if the delta is less than 0, then we know that if delta is less than 0, then the roots are imaginary. So which option is correct, ma? Yes, imaginary roots. Am I clear to you, children? Yes. See here next 17th question. If the roots of the equation, what is that equation? X square minus 15 minus m into 2x minus 8 is equal to 0 are equal. What they given? The roots of this quadratic equation are equal. Those two roots are equal they given. So here they given that quadratic equation, along with that also they given alpha is equal to beta, which means those two roots are equal they are saying. So those two roots are equal means we know that delta is equal to 0. Yes or no? Why? Because the given roots are equal. Okay, so depends on that condition. Here delta is equal to 0. Roots are equal. Already they mentioned in that question. Okay, so b square minus 4ac is equal to 0. Clear? So here b is equal to, but children here say that first we have to simplify this equation. Why? Because here x term is not there. Okay, so first we need to simplify that given quadratic equation. Okay, first we have to convert this one into general form of the quadratic equation. So first see that here x square minus 15 minus 2mx minus into minus plus 8m is equal to 0. So first simplify it. X square minus 2mx plus 8m minus 15 which is equal to 0. Understand? Now here x square ax square plus bx plus c is equal to 0. Now this is in the form of general form of the quadratic equation, right? So here b square, so b is equal to, so see here b is equal to minus 2m. Okay, and here a is equal to 1, c is equal to 8m minus 15. Okay, so substitute those values here. So b square is equal to minus 2m whole square minus 4 into 1 into c is equal to 8m minus 15 which is equal to 0. So here minus 2m whole square 4m square minus 4 8s 32m minus into minus plus 60 is equal to 0. Okay, so from this one here we can take that 4 as common, no? So m square minus 8m 4 8s 32 plus, and here 4 15s 60. So this is the required equation. So from this one we need to find that m values they are asking. No. So that's why find that m value here. So m square minus 8m plus 15 is equal to 0. Okay. So from this one m square minus, here the difference or sum must be equals to minus 8 and its product is equals to 15. So what are the possible values here? Yes, minus 3m minus 5m plus 15 is equal to 0. Clear? So from this one take that m as common. So m minus 3 minus 5 as common, m minus 3. Okay. So minus 5 into m is equal to minus 5m, minus into minus, that is plus. So 5 3 is 15. Clear? Yes. So m, which is equals to m minus 3 again in common. So next m minus 5, which is equal to 0. Now m minus 3 is equal to 0, m minus 5 is equal to 0. So from this one m is equal to 3, m is equal to 5. So what are the values of m here? So therefore m is equal to 3 or 5. Okay. So we can take here 3 comma 5. Understand? So that option is there or not? See here. Yes, 3 comma 5. Option 2 is correct. Those two are the values of m. So those two values also satisfies that given equation. Understand? Okay children, so in this video we discussed up to 17 questions. So the leftover questions we will discuss in the next video. Okay, thank you all.